Okay, so first off tonight, there's a storm moving past, and it has already knocked my power out once. So if I suddenly disappear, I will pull up my phone and be back on in a couple of seconds time. That'll probably affect the recording for those watching later, but it looks like it's about past now. It's just barely sprinkling, but it did knock my power out a few minutes ago. So until about 10 minutes ago, I was worried that I may have to start up do class from the phone, but power came back on, so I guess we can go ahead and get started. So looks like we're about halfway. Hopefully everything's going good. Nobody feels like they're falling behind in any classes. Are y'all's other classes going okay? I assume that means things are going well. Usually no news is good news, right? Oh, you're only in one class. Just kind of getting started. I think you mentioned that before. So I guess we can jump into the topics for tonight. The topic this week and the assignment this week kind of relates to it in a roundabout way, which we will talk about probably on Thursday. Might get to it tonight. But the topic this week is databases. Which is a big deal in the modern world, right? The oil of the 21st century. There's a lot of value in data, right? Some of the companies that a few companies have gotten notoriously rich from selling people's data. There's apparently a lot of money to be made from it, and even just regular companies keeping the data is important. Or on personal levels, like all the phone numbers I have stored in my phone. I wouldn't know how to contact those people without the phone remembering it, or the computer, probably a server somewhere, remembers all the email addresses of everybody I know. I don't know what those are. I could probably look them up or something, but it's a very important thing in the modern world. And I guess it reaches into next week's topic, where we'll be talking about software development a little bit next week. And that is, software development is kind of the manipulation of data, right? We put a bunch of instructions together for the computer to move data around, manipulate data, and we're working with that. And that's one of my favorite things to do on computers, is develop pieces of software. And it kind of feels like the artistic aspect is what I like. I get the same feeling developing a piece of software as I do with some of the traditional art forms, like painting a picture or writing a song. Just that creative outlet. And at least the way I feel about it, software development, data is the medium that we use to create a piece of art. I guess there's also usually graphical user interfaces involved there, but that's just drawing pictures, and usually very boring interfaces are the better ones because they're easier to use. We make our interface super fancy. The fancier the interface gets, the harder the software is to use. So that part's kind of boring. But I feel like that is the medium for that, for viewing software development as an art form. This is what I really enjoy about it. But this week, talking about databases themselves. So a couple terms to start off with. Well, we'll start off with the actual definition of database. I went and copied down the actual definition here, or some keywords from the actual definition. So it's a structured set of data held in a computer. Which is a kind of vague. And there's a technicality that I'll come back to a couple times this evening with database, that there's a lot of things that are technically databases that we would never call a database. So like file structures, the assignment, was it last week or 2 weeks ago? Whenever we did that, had that assignment to confirm that you could create some folders and organize several folders together in sort of a hierarchical structure. I'll do 2 more real quick. Just our basic file structures on a computer. Maybe down here at the bottom, we have a couple regular files inside of those folders once they're all organized, but in a hierarchical sense. That fits the definition of database. And technically, that's a hierarchical database. This is based off a hierarchy. But that technicality is about as far as it goes, right? We would never refer to the file structure on our computer as a hierarchical database, even if we're talking to other people that would know what that term means. It just technically fits the definition. But usually we mean something a little bit different when we say database. I'm going to kind of lead into that. So it has the structure part, and later this, at some point this week, maybe tonight, it'll probably be Thursday, we're going to look at spreadsheets as well. And they kind of fall apart with the structured part from being considered a database. So something, it's a very vague definition, but some things that we commonly use fit the definition, but only on that technicality. We would never actually call them that. So a file structure is technically a hierarchical database, but no need to go start using that term or anything. It might be a question on a multiple choice quiz. That's about it. But the key thing is held in a computer. So I'm going to put a star here and make the note storage. I also want to define another term that goes along with this. It's probably not in the supplemental material for this week, but something that often shows up that's very common in programming is the term data structure. Which technically is an organization method. Yeah, I'm running out of room, so I'm just gonna stop. Organization method that enables efficient access and modification of data. The keyword I wanted to write up here along with storage is a data structure is what we use in memory and processing, memory and CPU. So databases are for storing the data, and data structures are what we use when we're working with the data for processing and moving it in and out and around memory and the registers and all of that stuff. I wanted to include that word to talk about some of the types of databases here in a few moments. So basically, databases are where we store the data for long-term, non-volatile storage. The stuff that will still be there when we turn the machine off and then turn it back on in the morning. RAM is volatile storage. When we turn the machine off, that's going to empty out. The processor is going to reset when the machine reboots and everything. So the temporary stuff will be cleared out, but databases are for long-term storage. And this also relates to kind of how we use the word database. So escaping a little bit from the technical definition, like I pointed out the hierarchical database, we'd never actually call it that. We say folders and files, or if we want to get a little bit more formal, we might say directories instead of folders. But we typically don't think of that as a database. And this working with it, or the intention to work with it, is kind of what sets data apart and between our technical definition and actual usage, because we intend to do stuff with the data, which means there's a little bit more than just the symbols. And that's where like spreadsheets will fall apart. We're going to look at them later this week. We'll have a big table. Spreadsheets are kind of a big, giant table, and we put words and numbers in there. Even when we write numbers, it's actually all stored as text. So really, it's just the symbol. Like the stuff I'm writing on the board here, it's just the text. And any interpretation of that, pulling out meaning and everything, is on you all being able to see those words, those letters and symbols, and know what they represent. If we're going to work with it, the computer kind of needs to know a little bit of that too. The computer needs to know some of what those symbols mean, right? It needs to know which ones are words and which ones are numbers, and how they fit together, all that sort of stuff. So data has a little bit more than just the symbols. There's some other stuff included. For example, we could just type stuff up in the file and just let the letters make up that data, and then we can do stuff with it. So this is relating to an example I'm going to get to in a few moments. I'm going to go ahead and share my screen, just for a trivial example here. I'll just open the text editor. Got Notepad++ here. What is that? Oh, that's configurations for a touchscreen. I don't want to delete that one, but we could just store some data. I have some generic data I always work with for classroom examples, and just a handful of people with their name, age, town, and favorite food. That seems like good generic example data. So just open a text file, we can put that all in sentence form, right? Like Sally lives in Salem and is 23 years old and likes pizza. Something like that. The data's there, right? As humans, we can look at that, we can pull the information out of it. What's another one? Living in Charlestown is Charlie, who is, I don't know, 38 years old and likes cheeseburgers. I think I spelled that wrong. Oh, no, it looks like it's spelled right. And that could go on and on and on. I think y'all kind of get the point there. I didn't need to save that. Well, I guess that would be the next point, part of it, right? We go and save it. Documents, delete folder, which is just all kinds of full of stuff. And it's a flat file of data. So that's flat file format. We just put the symbols into a file, a text file, a Word document. We'll see a spreadsheet is really the same thing. It's just the symbols written there in a specific format. So we'll come back to this before too long, but it's just a flat file. As humans, we can look at those sentences and pull the information we need out of it. The stuff's written there, it's saved, so it's there. It fits our definition. It's structured. Those were grammatically correct sentences. The data is held in a computer. So that's the sort of flat file type of data. We just put the data in a file and store it there. Usually not what we mean when we say database, though, right? It's something more. It's fine for a human to interpret that data. If we wanted the computer to do something with that data, there'd be quite a bit of work. We'd need to parse through it. Another one of those vocabulary terms, and write it on the board because this is kind of a vocabulary class, learning to speak like an IT person. Parse, that means sort of search through a collection of symbols and look for the one you want. Right? So I just write out that data, some stuff about myself. We got my name, my age, the town I live in. So parsing that data, I could like parse the integer out of it. So the computer could read through there, and the first thing it finds are numbers. It could parse those into an integer to actually do some math with. And parsing just means that search through the symbols and find the part you want and convert it to the format you want. Like in that case, convert it to an integer instead of just the symbolic digits for 4 and 2. The order would make a big difference. That's one of the things where spreadsheets come as a flat file spreadsheets, or just when we have software write a bunch of data to a text file and then read it back. That sort of flat file, the order makes a big difference as opposed to those sentences that I've intentionally made up to be in a different order there. But it's kind of the same thing. There's a lot of work to get our data out of there. But technically, it fits that definition. We would just never really call that a database. And there's a whole lot of things that are like that, that they fit that definition, but we would never actually use the word database in that manner. So the basic versions of what we'd actually call a database would typically, we're thinking of a relational and non-relational database. I think I can write this without erasing everything. So relational databases and non-relational. These are the things that we would actually be thinking of if when we say the word database. They're also often referred to by the language that we use to access the data. So relational databases, we use what's called a structured query language, which I was going to explain a little bit more before too long. We often use anagrams in IT stuff. So structured query language and SQL, we go ahead and pronounce that SQL. It's close enough to the word. We can pretend like those verbs are there. And that's the family of programming languages we use to access data in a relational database. And non-relational databases, we often refer to as the same way. You'll often hear those called NoSQL databases, which means that we're using a different language to access the data from them. So the idea of a relational database, that's the main ones. Non-relational databases, there's a wide category of those. I'm going to talk about them in a moment. But mostly I wanted to talk about a relational database because that's what we use most often. So each data point is a field. And I'm going to come back and add another word here at the end here in a moment. Technically, we call it a field. So every data point is called a field. And related fields form records. Uh-oh. Didn't quite leave myself enough room there. Hopefully that won't be a big deal. I just have a couple pictures to draw over on that side in a few minutes. So hopefully I can go around that. Related records form tables. And with tables, we usually think about rows and columns, right? I'm going to draw a couple of them, so I'll go ahead and draw one. We usually have a bunch of columns all line up in rows, and we put each organize our data that way. So each one of these cells is a field, So a field, we could also call that a cell or a column. Each column is a field. Then all those fields are connected. How we connect things to form the tables. And each record is like a row. So either a cell or a column for each field, and each row is like a record. So we build these relationships up. Then tables are related by common fields. Tables are related by common fields, which again, I didn't leave myself enough room there. Hopefully that's somewhat legible. So you can see the relational part. We start with each particular field or cell in this big grid of tables, and related fields add up to form a row, which we call a record, and a whole bunch of records add up to form a table, and then related tables we connect with fields. So each data point gets its own cell. So we have a field. Hopefully these colors are showing up. I'll try orange. And then we can add a bunch of fields together and build up records. What's another color that will show up? I think this one showed up if I drew it really dark. It looks like it's showing up, different than the orange. And then a bunch of those records, I think I have to do this to make the dark colors show up on the picture. Does that show up? Yeah, it's on there. Which all line up to form that nice big grid again. Form tables. And we build up collections of our data that way. And then common fields, it seems a bit redundant to have the things there more than once, but that redundancy, so maybe this column here is the same column data as this. And that allows us to connect those different fields so that our tables are connected. And it's a highly structured, organized method. And it allows the computer to jump to any particular cell, right? We can, by these connections, right? We could be looking at this piece of data, and that connects over to this other field, which following the arrows around connects here. Then we could find this piece of data right here from all those relationships and connections there. So it's highly, highly structured, and the computer can jump right to any data point in any one of the tables, can jump right to any one of the cells. So it's very, very quick to retrieve our data when it's organized like that. And we retrieve it by making queries. I may have a little bit of room up here. So a query is a criteria-based question. Criteria-based question. And separate that off a little bit. I guess I need a full box around it. So example I've jotted down quickly when I was putting these notes together is, so a question would be like, can I get a steak at Applebee's? That's a common question, right? There's a yes or no answer to it. A lot of people would know the answer to that, but it's just a basic question, very generalized. A query, on the other hand, would be, can I get a steak at Applebee's for under $12. That under $12, less than or equal to $12 to put it in mathematical sense. There's a criteria that we can distinguish that question, distinguishes questions and queries. And that's where that language comes from. The structure, I was just talking about all that structure part, and we use queries on that structure to very quickly pull out related data, and then the L stands for language. That's just, we program in languages. So that, that's how we use those. And I was going to look at a simple example of that tonight to compare to that to spreadsheets. And then I'm thinking Thursday we'll look at spreadsheets. So most people in our society have probably seen a spreadsheet or two, right? They're everywhere, not just for accountants anymore. Non-relational databases, on the other hand, talk about those. So earlier I mentioned this other thing, data structure. That's how we need the data when we're moving it in and out of memory and doing processing with it over in RAM and CPU. Now, random access memory and central processing unit, we need it in a data structure form. Definitely not a table form, right? This big table filled with thousands of entries of random data points would fill up our RAM pretty quick and start to slow down the computer. So we just need bits and pieces of that, but we put it in data structures to work with it. And there's a bunch of them depending on what you want to do with it. A couple of terms we're not really going to get into in this class, but that you'll hear eventually, depending if you want to organize, just to organize or keep it around. We have sets and lists, vectors and maps, arrays kind of fit in there too. Just some words you'll hear somewhere down the line. So preview mode for the whole IT vocabulary stuff, I guess. Or maybe our goal is to optimize what's going on in memory and processing with them. And we have stacks and queues and a whole bunch of other things to work with there. Stacks being like a stack of plates, right? After we wash the dishes and go to put the plates up in the cabinet, we stack them up, and the last plate to get washed and put away is probably the first plate to get used. So the last one, so in a computer, it's a similar thing. The last instruction to go in is the first instruction to get processed. And a queue is the opposite. It's like the line at McDonald's, a nice organized line in the drive-through or something, where at least in theory, the first person there is the first person to get their food, and it goes in the order of arrival. So we can process through our instructions the same way, just some terms for that. Or maybe our concern for moving it through the processor is just speed alone, in which case we might use trees or graphs. We have all these different data structures, these different ways we can organize our data to use in our code, which are not organized like this, because that's for efficient retrieval. That's so that we can retrieve it really, really quickly, but we can't really work with it really, really quickly in that format. So one of the main ideas in non-relational databases is, well, if we need it in this form to work with it, why don't we just store it in that form? So we often use like object-oriented programming is the term for one of the most common types of software development. So we need our data in objects to work with it. So we can create an object-oriented database where we just take that object that we want to work with in our program and store it directly in the format from the program. And don't worry about any of all this other stuff. Or however we have it set up, however we have it stored, we can just, or however we work with it, we can just store it in that same format. And obviously it's very specialized. It's for kind of specific purposes, but you know, depending on what we're needing, because if we're storing it in the form we need it in for a particular piece of software, then it's only going to be useful for that piece of software. A different piece of software would probably need to modify it a little bit to work with the same data. We may have a bunch of objects connected together, which would almost be like a flat file section. I'll draw them something like this, little boxes, and then we have them all in files, and we can just retrieve them as we need them. And skip, it slows things down at the retrieval step, but it speeds things up at the processing step. So the trade-off kind of ends up being worth it. Or another one I wrote on this other piece of paper. What else did I have? Object-oriented stuff. So object-oriented, flat files, or networks. Those are common. So we could have these different data points scattered around and then have different ways to connect all this data together. Lots of different connections coming through everything. And that's usually called a network database or a graph database. Actually works on graph theory, mathematics. So, well, that'd be the technical term for it. But a lot of people just call it a network because it looks like a network diagram. But in those cases, it's these connections between our data points that get the main focus for retrieving that data and how we single out a piece of data like we were doing with structured query language. That's kind of just the basic idea, of quick overview. The most important part is just remember it's storage thing. So there's a few words that should stand out, that should just pop out in your mind, like storage. How much storage do we have? What's the volume of storage? How much data is going to be stored? Because, well, like I pointed out here, we'll need some redundancies in order to get the quickest type of retrieval for it. But we want to minimize those redundancies and things like that. So the volume, the assortment of data, how much is in there, the variety of it, because I made that point earlier. I don't think I have a picture on the board that relates to it, but about how data is more than just the symbols, right? It's more than just writing the words in a text file. The computer knows a little bit so it can work with it. That might make a little bit more sense when we look at an example here in a moment. But a couple starting points just to kind of a broad overview. I tried to limit myself because data is one of the points that I find very, very interesting. That's one of the things I found most interesting in computers is all this stuff with the storage and retrieval of the data and how it can work through very large data sets. Like, well, the example we're getting ready to work through here is going to be small, right? It's things that we could probably almost do keep track of in our head. But one example, when I was taking a class on a language called R, just the letter R, it's a statistical analysis type of software. The data sets we used for the class examples were cholesterol data from the CDC. They took out any identifiable information. So we didn't have people's names, but there was the date of birth, the numbers to calculate body mass index, so height and weight and all that stuff, the HDL and LDL levels, the actual cholesterol values, and then where it applied the date of death. So it wasn't just a data set as big as America. It was all the data that's ever been collected. So it was going back to probably back to the 30s, when in some of the big cities when they started collecting that stuff. So people, more than just the current American population size data set. When we get up to digging through data like that, things can get it can really start to slow down a computer, right? Even though they're big and can handle a lot of things, if we have, well, there's 7 billion people on Earth, everybody's got a name. Like example, we're getting ready to work through here in a moment, just uses the name, age, town they live in, and favorite food, we'll do 5 or 6. But if we did that for 7 billion people, because all 7 billion people on Earth, or more than 7 billion people on Earth, all have a name, an age, town they live in, food they like, and that would really start to slow down some computers, right? That's a huge data set to deal with. So we looked at the flat file here, and we can just kind of write stuff out, or we can put it in a more organized form. We'll see that when we talk about spreadsheets in a little while, but relational databases are a really nice way to store the data, because it's still, usually it's still human readable, excluding encryption. There's some things we obviously want to encrypt when we put in there, or sometimes we'll just store things straight in binary format and leave it in the computer format instead of the human format. But in general, it's stuff written in a table, so it's somewhat still human readable. So a human can look at that big grid of rows and columns and do stuff with it. And we have the speed of the computer to dig through and single out any particular data point in those. So that's sort of our standard for what we think of with the databases, relational databases. So what I was going to look at is the software that you probably have access to. Did you all install the Microsoft Office 365 stuff for this class? You get it free from the school, so the Microsoft Office stuff, or we looked at a couple other alternatives. So there's more alternatives we can work with. But one of the things in Microsoft Office Suite is this software called Access. Have either one of you all used Access before? I should have, okay. So this is a relational database. It's set up for relational databases. It has SQL, which runs on the back end. So we drag our mouse around and click on buttons, and then it writes the structured query language to retrieve stuff from the database on the back side. But there are a couple differences for working with databases. It can be really useful to know. So if you downloaded the Microsoft Office stuff from, or downloaded the free license for Office 365 that you can get from the school here, or it's available in open source software as well. Office Libre has a nice one that is very, very similar to Access. But it's a good thing to practice around with. And you can see there's a bunch of templates to get started with, like contact lists, event management stuff, more templates. Let's see what's on more templates. And they're not fancy looking like the Excel templates. We'll look at spreadsheets here in a couple of days, and spreadsheets are just the text. So one of the advantages of that is we have a lot of options to format it and make that text, make those symbols look really nice on the page. But there's a lot of stuff in here. So list of books, tasks, diet tracking things, and a good way to learn software and just kind of mess around with it, kind of see where stuff's at, is instead of starting from scratch, maybe open a template and play around with that some if you have that on there. I'm just going to start a new one and kind of go through some of the big steps. So notice the first thing is a little bit different because in most of our Microsoft Office, right, if we open Word, it opens a document, we can start typing. If we open Excel, which we're going to look at probably on Thursday, it's already 6:40, so probably on Thursday, we just open it up, have the spreadsheet there, and we start typing and stuff, and we don't give it a name or stuff till we save it, because most of the time we're working in RAM, we're working in memory, and then we only move it to storage when we're ready to. But a database is in storage, so we are working directly in storage. So some things work a little bit different. Microsoft Access draws an undo button there. Some of these similar ones, like Office Libre, I think they just leave their undo button off. Microsoft Access draws an undo button, but it usually doesn't undo anything because we're not in memory. We can't go back a step. We already saved it to the hard drive. It's saved. It's set there. So that's one difference is we're working directly in storage, not in memory. So some things are a little bit different. That's why it's good to kind of practice around with it. Why I wanted to look at it the same week we looked at spreadsheets, so you can spend a few minutes clicking buttons here, spend a few minutes clicking buttons on a spreadsheet and kind of see the difference between them. Because a spreadsheet really is just the text. So I'm going to go over here to my Scratch folder. I just have this folder, working folder of things to delete next time I clean up. Every couple of days I clear them all out. Once you give it a name, probably something better than Database 1, just hit the Create button to start a new one. And we're looking at a table. We can add some stuff here. If we click up here, we can add, well, see this list of things we can have. And it's not just text. I've made that point several times now that in a spreadsheet, all we have is text. There's some stuff in the background so that if we want something to be a number, it will try to turn it into a number, but really it is just text. We can reformat it. If we have a number there, we can put a $sign and commas in it without affecting anything because it's just the symbols. And anything that we want to do with it has to happen in the background. But with the database, we need that a little bit more. We need this stuff. We need to say it's, first thing I'm going to put here is a name. So we need to, I'm going to ignore that warning. I'm not supposed to use reserved words, but really it'll be okay. We have this name that is a text file. So notice there's some buttons here already. There's no data in there, but it knows that if it's text, there's an alphabetical order. There's going to be an alphabetical order to that data and things like that, or other filters. If it's text, we might be able to, we can look for a certain character in it at the beginning or end or different things. So this is just building up a table. We can do it all here. A better place to look at it and get a sense of that is on the Home tab. This very first button says View. We have options of Datasheet View. That's what we're looking at here. That's just the big grid of rows and columns, the records and fields, the cells on the table, the big grid view. Very boring to look at. Or we have Design View. And I'm gonna switch over to Design View. I'm gonna give this a name. I'll call it People. And here we see some things about it. So one of the things I didn't really mention on the board is every one of our records, we need a way to identify that, something unique. It's kind of small, but you might see here, there's a little picture that looks like a key. We call that a primary key. That's a unique identifier that can, that makes every single record in our database immediately identifiable. So I'm going to just call that person ID. And by default, it's set to an auto number, auto increment a number. It's going to call the first thing either 0 or 1. I'm not sure what access does. It's going to start at the beginning of numbers and just 1, 2, 3, 4. Every record we add to that data will get another number. I'm going to change that to text, and then I'll just manually type something in. And notice down here at the bottom when I change that. So it was an auto number, and the computer knows some stuff about it. So whatever's there is an integer. We're just going to automatically increment it for new values. We can put some formatting things on it. So it's a number. We can put $signs and commas if it passes 3 or 4 digits or something. Different things. Put some text that'll pop up if we hover over it. to reply meaning. I'm just going to type something in. So I'm just going to change that to text. We're going to talk about people. So do like, I don't know, adult male, number 1. So AM1 or YF3 for young female. Just some number alphanumeric code I'm going to make up to uniquely identify each record. Then name, that's a text. That's just going to be text. That's how we write our names. Age will be a little bit different, right? Because age, you might want to do some math with people's age, or two people's age. I might want to find out the difference between their age, subtract it, or do the standard mathematical comparisons of more or less. So that, I actually want to make that sure that's a number. We have different types of numbers, large numbers, dates we want to treat differently than text, because dates are something very specific, very special, right? If we have like a database of customer sales, we might want to know stuff from 3 months ago and be able to hone in on like March or something. And the computer needs that little bit extra background stuff. That's the big difference between just text, just having symbols, and actual data, because the computer knows a little bit about it. But notice when I highlight that row, it gives us different options. Down here, it's an integer, automatic for a number of decimal places, starts with the default value of 0, and then a bunch of other things about it. Whereas on that name field, it tells us how many symbols we can put there. We can put up to 255 symbols. We'll probably make that shorter for most people's names and not really waste space in the database. I'm not going to worry about that now. But there's all that other background information. And then town, which again would be short text. And there's some other things that aren't really working into this example, but sometimes you want to think about the type very carefully. Zip codes, those are all digits. I'm here in Clarksville, so the zip code's 47129. It seems like a number, but it's not really a number, is it? We can't do math with it. We can't add 2 zip codes together and get anything meaningful. In most cases, we'd end up with an extra digit and not even have a zip code anymore. But even if it was still only 5 digits long, it wouldn't be in any way meaningful to the 2 zip codes we added or subtracted in order to find it. So even though it seems like a number, it's really just text. So we want to make sure we're treating all our data kind of the same way. That gives us sort of like a structure here. I'm going to close this, save this, and then we can add that, add some data points in. I'm just going to make up a couple things. So like, I don't know, adult female 1 is Sally, who's 34, lives in Sellersburg. So this is where we have the big table of data, and we can just enter it this way. Adult male 1, Charlie is 28, lives in Charlestown. What's next? Adult female 2, or maybe young female 1, Abby, who's 13, lives in New Albany. And yeah, I'm just making these up right off the top of my mind. Young male 1. So some alphanumeric code to uniquely identify everything. And that's a primary key so that we know what all our data is. I don't know, Jeff who's 11 from Jeffersonville. And we can fill up this table with lots of data. you can keep making names up for a minute. But I just added a bunch of things to it, right? And in Microsoft Word, if we open up something that was there, typed a few sentences, and then go to close it, it's going to prompt us to save that, right? But if I go and close this, it didn't ask me anything about saving. And that's back to that point that a database is in storage. As soon as we type stuff in the table, it's in storage directly. There's Microsoft draws in the undo button up here, but a lot of times in databases, the undo button doesn't do anything because we can't walk back the steps in memory. Like when we're in actual storage, because we already erased what used to be there and saved something new. So you'd have to be careful with that. I'll create a second table for an example and tying things together. So I can come over to create a new table, and I'll switch over again on the home tab under view. I'll switch over to design view, and I'll just call this taste. So we need a way to tie things together, right? Over in that people table, we had that unique ID. Every person got a unique identifier. So I'm going to put that same field here. And that way I know these tables will always be connected, which was short text. And I don't know, I'll just put one piece of data here. Favorite food, just fill out their, whatever the favorite, list out their favorite food. There's a table, yes, save that. So now we have this table we can add some more data to kind of match the people table. But one thing, working with a grid like this is, it's not a very good format to work with, right? So we also have the option of creating forms. If we go to the Create tab, we can just create a form. There's wizards and stuff that'll help. I guess the generic one's not much better than the table view, but we're looking at one record at a time, and we have nice labels and boxes to type in. You can kind of see them that way, and makes it a little bit nicer to work with. Sure, I'll go ahead and save that as people form. Just a little bit easier than working with the big grid itself. So I'll go ahead and do that same thing for this other table. With it selected over here in the list of all the things we have, just create a form, and this generic form will work. We can use this to enter the data instead of going right into that table, which is just an appearance thing. What do we have? We had an adult. I have to save this first. Paste form. If I open this, okay, I had to save it first, and now the cursor's there so I can type stuff in. So we had like, I think there was one adult female and one adult male. So I'll put that same adult female one, maybe likes pizza, and tab over to the next one. See down here, record number 2. Then we're in the taste table. I close that and then reopen it. Typing it in the form added it to the table, so everything's connected. It can be a little bit easier to work with the forms than the tables directly. Like adult male 1 likes cheeseburgers, and I'm just making this up. What else was there? Young female 1 likes I don't know, tacos, and young male 1 hot wings. That's a few things. So if I open up this table, we can see we have that data saved there. And if I open up the taste table, we can see the data is saved there. We can read it. And when we look at spreadsheets, that's kind of what we'll have. We'll have all the data entered in cells like that in rows and columns and organized in different manners. But what sets databases apart is that little bit of extra stuff where I said that these are words, they're short, these are actually text, and this one's actually a number, so we can do things with it. And that's getting into running queries. Now that we have some data in there, I'll kind of point at that button. If we go to the Create tab, there's a little wizard to kind of walk through the steps, make it easier. If y'all start playing around with stuff like this, you can give the wizards a try and see what's available. But there's different types of queries. To start with, just testing things out, we'll do a select query. So as you're playing around, make sure that the select option is chosen. Took me a minute to think of a different word there. And then we need to add some tables to search through because all of our data is over in tables. So over on the right, or depending on how you have it set up, there might be a list of tables pop up as a dialog box. Or up here in the menu, there's a button that says table names. Somewhere you'll see a list of the tables, the data we have. And if we click on that, we'll bring it over here. And for each record, we have an ID, a name, age, and town over in our people table. And then in our records over in the taste table, we have a person, the ID, and then their favorite food. And I was careful when I set that up to make sure the person ID is the same in both of them. So we can actually form a connection there. So if I just click on this and drag it over, notice the symbol looks like it recognizes something. It's not the circle with the line. When I do that, it forms a connection between those two things. So those tables are connected so we can do things with them. If I click on it, it's looking, well, the default one, include where the joined fields are equal. So it's going to look for where those are equal. So like if we drag down a person's name and their favorite food, it's not going to pull everything separately. Then once we ask for the data we want, we get our tables in, just grab the fields you want and drag them down here. And these are the ones that kind of show. I didn't mean to do that last one. Leave that. So maybe I don't want all the data. I just want to know the person and their favorite food. And once you get the fields you want, I click this button that says run, and it'll quickly sort through the data and show us like Sally like pizza, and Charlie like cheeseburgers, Abby like tacos. We could go through those tables and make sure that all connected, but see how it was able to very quickly sort through and find that data. If we go over to the view button here, notice there's a couple views. There's the data sheet view, but again, that's just looking at the big table, the grid of rows and columns. We also have SQL view. So all that dragging around actually typed this code up. We could have just gone here and typed those words directly. It takes a minute to learn all those words, but I think a lot of you all will probably see that in a class at some point. I believe database classes are required for most people for some reason or another. And then design view is that thing we were looking at a moment ago where we're dragging everything around. Maybe we didn't want to know all that, right? I pointed out that a query difference between a question and a query is we have criteria involved. And there's no criteria here. We just said, well, what are the names? What are the favorite foods? Maybe we could add a criteria about the age. So that's the row labels. There's one for criteria. Say age less than 20. So we only want to know this about people under the age of 20. And then right above that criteria row is this show. So we know everybody we're asking about is under 20, so we don't really need to see their age. We just only want to know about that for people under 20. So we don't necessarily have to see all the data we're using is what either. But you'll notice there's a lot of just dragging things around. So I come back over here and run that query again. Now we just see those two young people and their favorite food, and we can go back in design view and add other information, like what town they live in. And it gives us a way to organize and sort through our data. A very organized method, and I just kind of wanted to point you towards it. And hopefully that kind of made sense. The main thing is, oh yeah, and then once we have queries, we can save those. So like if I close this and save that as a query one, that'll work. So along with our tables, we can go back and immediately access that data we've already asked for. So we don't have to ask this in the same question over and over and over again. It's kind of saved in there. But the main thing is that relationship. We set up all this data, names, ages, and towns, along with the unique identifier. And then that unique identifier allowed us to form this connection between the different tables so that we could very quickly sort out our data. So that is probably a good one to kind of play around with a little during our lab time. If you have access on your computer, is anybody using other software like open source software or something other than the Microsoft versions? So you can get this for free as an IB Tech student. If you're using like Office Libre, the open source one I've mentioned a couple times that first week, I think, it has a very similar thing called Base, which is the interface is very, very similar. You set up tables and run queries to make forms because it's really aggravating to work. Over time, it gets aggravating to work in the tables directly. Our eyes start to get blurry. Everything blends together, so we can make it look nice. That's all the forms are for. It's just making it look nice. So you just want to, play around with it. Create a couple tables of data, or use those templates to set up a contact list or inventory of books or something. Just some random practice data to see what the buttons are. Right? That's how we learn. Best way to learn computer stuff. And if you go to the Create table, most of the stuff you'll need to start off with is under the Create tab. Just go to Create, and you can create a table and maybe a couple tables. Then after you have the tables, you can go to Queries, and well, again, you can use a wizard as well, which is just the dialog box where you just keep it. Select a few options, hit Next over and over and over again until you get something in the end. Oh yeah, I guess there's one other thing, the reports. So we can also just generate a report. I'll highlight that query here and then select the report button, and it creates, well, it doesn't look that nice, but something that we can print out, right? Something to send to the printer that looks nice on the paper to pull out at a business meeting or something and kind of see the data in a nice form. Sure, save that as query one report. And then there's a lot of customization features and stuff, but for the most part, for playing around with it, just go to, when you create a new one, create a bunch of tables, and then mess around with running queries to see what sort of data you can pull back out of there. Because on Thursday, it's already after 7. I was looking to talk to about 7:15, and I think that was the last thing I had on my list here. Oh, Mercy must have lost signal. Hi, Mercy. Did it cut off on you?
Our power was out. I'm sorry about that.
Oh, yeah, that happens sometimes. I was on a Zoom call the other day with somebody that just automatically, he's got in the habit of signing on with 2 machines every time because he's got so used to getting kicked off of Zoom calls If he's on his phone and his laptop at the same time, usually one of them will stay on the Zoom call the whole time. But yeah, I was just kind of finishing up. This is something to play around with, right? Data is the oil of the 21st century. We kind of want to know how to work with data. And on Thursday, we're going to look at spreadsheets. So to help distinguish the difference between the tables here in a database and the table on a spreadsheet, this will be a good one to work, just kind of click around on in lab time. If you have access, or a lot of open source software has similar things. And there's much more advanced databases versions as well, but these Access is one that we can get for free from the school, or LibreOffice is an open source one that you can use for free that's not a Microsoft product. I think a lot of people like open source for that reason. It's not Microsoft or Apple. They have a software called Base, which is almost identical to Access. And you want to go to the create options and create some tables, fill them up with random data to practice on. List of things to do, a to-do list of chores around your house, or random inventories of things, contact list, things like that, just to practice with. And then run some queries on that data to see if you can get the computer to answer questions for you based off the data you enter in it. Because it's something you'll want to actually open it up and click around on the software to get familiar with it. Because like I've said, I think every class this semester, this is an active subject we learn by doing. That's why I try to make sure that there's plenty of time in our scheduled slot here to just click around on stuff. So yeah, I guess that was what I had on my list for tonight. I was thinking it would go to about 7:15, but that looks like I underestimated the time a little bit, which means more time for you all to click around on stuff and kind of get a feel for it and see what's going on. Just take a look at the software. That way you're not completely lost if you ever have to use it one day. That's my recommendation for the lab time, but wherever your interests lie. Please spend the next, hour and a half, basically, learning IT stuff. Whatever interests you the most, this is lab time to just do stuff and learn. So please be working on learning IT. And if you have any questions, whether it's the stuff I covered tonight, or whatever if you're more interested in something else and going to work on that for a while, feel free to send those questions my way as well. I will be sitting here till 8:50 as normal, ready to answer questions. Ivy learning messages and text messages make noise on my phone. I can jump back on the Zoom call in a couple seconds. But otherwise, that was all I had for this evening. So any questions? All right. I'm going to recommend giving that software a try, because databases will be very important no matter where you're heading in IT. You're going to need to keep track of some data. And Access is a good small scale one with an easy to use interface to get started with. And if you have any questions, just let me know. I'll be sitting here till 8:50. Otherwise, y'all have a good evening. I'll see you on Thursday.
Bye.
Thanks.